students, welcome to today's class, which will be the continuation of the last class, the class I started recently. In that last class on indices and exponential equation, some of the questions were left behind. So some of those questions are the questions on the board right now, so we are going to attempt them. In the last class, we were able to consider questions on indices only, and we haven't solved any of the exponential equations that was written as example. So, but before I continue with these exponential equations today, I would like to remind us of what we learned in the last class, the laws and some other stuffs, so that we remember. So we learned power multiplication of numbers with the same base but different powers. X, A, Y. We learned this also. We learned as well as we also learned this. Alright, so this we said that since they have the same basis, we pick one of the base, and then since it is multiplication, the powers will be summed. So that's x plus y. And for this, we said that it's the same like this, just that the multiplication is division here. So when it was multiplication, it was addition. Division will be subtraction. So we pick one of the bases that are similar. Since they are the same, we have x, and division here gives minus y instead of plus y, like the other one. So here, I said minus 1 means 1 all over. So when you minus, this minus means 1 all over. So when you cover the minus, what do you have left? When you cover minus, you have a raised to the power 1. And so a raised to the power 1 is the same as a. A raised to the power 1 is the same as a. So this will be a. Okay, that's another law. A raised to the power 1. Any number raised to the power 1 is that number. Is a. That's another law to take note of. So that's this. Then any number that is raised to the power 0 apart from 1, apart from 0 itself is 1. Any number raised to the power 0, yes, any number raised to the power 0 apart from 0 itself is 1. So what I'm trying to say here is, if you have 5 raised to the power 0, the answer is 1. 3 raised to the power 0, the answer is 1. 2000, whatever, however big the number is raised to the power 0 is 1. This is not degree, raised to the power of 0, so it's 1. Now, but if it is 0 raised to the power 0, it's not 1. So that's what this means. This means that if a number raised to the power 0 is 1, that number cannot be 0. So it can't be 0 raised to the power 0. But any other number that is not 0 raised to the power 0 is 1. So that's what it means. Now, this one also, we learned that this one, whenever you have a raised to the power, a fraction that has 1 as the numerator, your answer will be the x root of a. That's just it. X root of a. So what that means is that if you have 4 raised to the power half, for example, it means, well, let's say 16 raised to the power 1 over 4. This means just put the 4 here and then 16 here. So what the answer here, I said the answer here will mean the number that you multiply with itself by itself 4 times and give you 16. That number is 2. So the 4th root of 16 is 2. So that's that again. So now let's come to this one. We said this will be the denominator here, just like this one is when the denominator was x, the denominator came in. So the denominator here is y. You have the denominator to come to this place. Then you have your a in the square root and the root, then the numerator x here will be the power here. So that's that. Now for this one, okay, let me put that one down so that you don't forget it. Okay, so this one, the minus here will make this turn to 1 over a x over y. Now this itself means what? This denominator here itself is just like this, and it means that y will be the root, a will be in the root, x will be the power. So that's what this is. This. Then lastly, I also said that whenever you have a number with this power in brackets and you have another power, external power, So you multiply the two powers. The answer will be AXY. So like I said, all these letters are meant to be numbers. So whenever you are dealing with them, you just obey this way. Whatever this says is what you do. Alright, so now we can proceed to indicial equation. Now for indicial equation, if you have something like exponential equation, if you have something like let's say 2 raised to the power x plus 5 equals to 16. When you have something like this and you are looking for the value, you are looking for the value of x. You want to get what x is here. What's x here? Alright, so what we do is you look at the base. The base here is 2. Is there a way you can express this 16 to powers of 2? That's like, is there 2, because this is 2, you look for how you can turn 16 to something like 2 raised to power something also. And even this is 4, you may think of how you can turn 16 to 4 raised to power something. So what you do is, you try to see if there is a way you can express the power of 2 and it will be 16. How can 16 be powers of 2? Now look at it. I will just write this 2x plus 5. Then 16. I would only explain this the very first time. Some other time I won't explain them again. So please make sure you are paying perfect attention. So I am going to turn this to something like 2 times 2 times 2, 2, 4 times 2, 4 times 2, 8 times 2 is 16 now. So 2 times 2 times 2 times 2 is same thing as 16. So this is exactly the same as this. Now I can proceed. Why am I using 2? Because the base here is 2. That's why I'm turning my 16 to 2 forms. Now, 2x plus 5 equals, this 2 here means 2 raised to the power 1. The 2 here means 2 raised to the power 1. The 2 here means 2 raised to the power 1. 2 raised to the power 1. Remember the law of indices, the one I just created this morning, and we have learned in the past also. It says that whenever you have the same base, you bring one of the base and you add the powers for multiplication. X plus 1. So that's the same thing I am doing here. They are all 2 raised to the power 1, 2 raised to the power 1, 2 raised to the power 1. So I'm bringing one of the 2's. I'll bring 2, one of the 2 out. Then their powers, I will add them together. 1 plus 1 plus 1 plus 1. So that would be 2 raised to the power 4. And you have the 2x plus 5. Now that the bases are equal, the next thing you do is you cancel out the base. So equating the base. Equating the base means these 2 would have cancelled these 2. So you will just be left with, x plus 5, their powers, x plus 5 equals to 4. Then you collect like terms. When you collect like terms, you have x equal to 4 minus 5, because plus 5 will cross to this side, and the plus will change to minus x. So x will be left here, equal to 4, then the plus will cross and change to minus 5. So 4 minus 5 is minus 1. So x is minus 1 in that case. X is minus 1. So this is the final answer. But to be sure that you are right, you do what? You write the question back to be sure that you are right too, but that's the answer. 2x plus 5 is 16, right? Okay, let's see. So you replace this x with what it is. X is minus 1. So let me put it, instead of x, I'll write minus 1, then plus 5 equals to 16. Let's see whether it is true. 2 minus 1 plus 5 is 4 equals to 16. 2 raised to the power 4 means 2 times 2 times 2 times 2. Is this so or not? It is. 2 times 2 is 16. So that is to tell you that your answer is correct. So x is minus 1 here. So I really hope you understand it. Alright, so let's go. Okay, let's take another instance. I've already said that whenever you are watching this video and you need to write or jot down somewhere, you need to pause immediately after the solution so you can write it down carefully, because I won't wait before taking the next exam. Okay, so let's think of another question. How about when you have something like 4 raised to the power 3x plus 4 equals to 32. So this is another case. This is another case, another situation. Of course, just like I explained earlier, you would want to do just what I said before, but sometimes that doesn't work straight. So look at this, for instance. If you have to try 4, because I said this is base, this is 4, the base here is 4. So you need to look for how this 32 can be reduced to maybe 4 raised to power something, and it will still mean the same thing to the powers of 4, and it's going to mean the same thing as 32. So if you try that, you see that it doesn't work. 4 times 4 is 16. 4 times 4 is 16. Then you multiply it again with 4. You realize that it is 64, and it's already greater than 32. The 64 is already greater than 2. So what it means is that will not work in this case. Alright, so what you do next is, you now think of another way of going about it is, you look at it that, is there a way you can express this as power of a number and this as the same power? That's like in the form a raised to power something, then 3x plus 4, where this a raised to power something will be ordinary 4, will mean 4, and then a raised to power something again will be exactly 32. So this is what you do in this case. You think of it that, is there a common number, a number that you can raise to powers, to different powers, and when you raise the first one to a particular power, it will give you 4. The same number to another power, it will give you 32. So looking at this, you realize that 4 has only, let's start with the 4. 4 has only 4 factors. Only 2 factors. I mean 3 factors. 1, 2, and 4 are the factors of 4. Now, when you raise 1 to power, what I mean by 1, 2, and 4 are the factors of 4 is that multiplication table of 1, 2, and 4 are the only things that can give you 4. Another thing is that, another way of explaining is that the only 3 numbers that can divide 4 without remainder are 1, 2, and 4. Okay, so these are the 3 factors. So when you multiply 1 times 1 times 1, you continue to get 1 continuously. But if you check 2 times 2 times 2 can give you 4. 2 times 2 can give you 4. But when you say 4 times 4 is already more than 4, so you can't use 1, you can't use 4. You can't use 1, you can't use 4. So you can only use 2. 2 times 2. So this 2 here is, this 4 here is the same as 2 times 2, and you have 3x plus 4. Now let us see that same, remember this thing I wrote before, that you want to express in the form ax 3x plus 4. Let me use another letter here. Ak 3x plus 4, where ak is the 4. The whole of ak is the 4. And equals to that same base. It must be the same base, at. So that means a to the power of a number will give you 32. Now the a we are using here is, since it is 2 that I used for 4, let me see if 2 can produce 32 also. And you realize that it can. 2 times 2 will give 4, times another 2, 8, times another 2, 16, times the last one, 32. So all these 2's will give us this. So you put 1, 1, because 2 raised to power 1 is still 2. 1, 1 as their power. Then you can put 1, 1 here also. So this will mean, from law of indices, we pick one of these 2, and we add their powers, 1 plus 1. Then we put our power, 3x plus 4, right? Equals to, all these are 2s, they have the same base. We write one of the 2, and we add all the powers, 1 in 5 places. Please, I may not explain this again when I start my explanation, but you should know why it is like this. Alright, so this will be 1 plus 1 is 2, 2 raised to power 2. Then you have 3x plus 4 equals to 2, 1 plus 1 plus 1 plus 1 plus 1 is 5. Alright, so now, this is looking like one of the laws I stated earlier, ax and y. I said you multiply the 2 powers. So that's what we are going to do. We are going to multiply these powers, 2 and this. So when I have this 2 is here, Now the powers are multiplying each other. 2 times 3x will give you 6x. 6x. 2 times 4 will give you plus 8 equals to 2 raised to power 5. Now the base are equal. Equating the base. So we equate the base. Equating the base. Equating the base means these 2's are cancelling out. So that you have just the powers left. 6x plus 8 equals to 5. And so because of that, you have to collect like terms. So on collecting the like terms, you will bring this plus 8 towards this side. That will be 6x plus 8, 6x equal to 5 minus 8. 6x equal to 5 minus 8. So 6x will be 5 minus 8 is minus 3. Minus 3. So minus 3. Now, in order to make x the sort of formula here, you divide both sides by the coefficient of x, which is 6. So divide both sides by the coefficient of 6, coefficient of x, which is 6. So 6x equals to minus 3 over 6 over 6. 6 will cancel 6, so that x is minus 3 in 3, 1. 3 in 6 is 2. 3 in 6 is 2. So the answer is negative r minus 1 over 2. That's the answer for this particular question. So, if you've understood this, my examples, then we'll be able to answer the questions. You'll be able to understand the questions very well. You can pause the video if you need to write. Alright, so the next question, the main question now. So the first question is 5n plus 3 divided by 25 raised to power 2n minus 3 equals to 5 raised to power 0. 5 raised to power 0. Alright, so we would have seen that we have this, we have 5 raised to power 0, we have 5 raised to power something, we have 25 raised to power something. Alright, so here we can rewrite the left hand side here, this left hand side, as though it is like this: 5n plus 3 divided by 25 2n minus 3. This over is the divide here, equals to 5 raised to power 0. Alright, so now everything here is 5 to the power of something, apart from 25. So is there a way we can represent 25 as powers of 5? Yes. Alright, so let's see. 5n plus 3 divided by 5. 25 is the same thing as 5 times 5. That's 5 in 2 places, so that's 5 squared. I've explained it in the recent example. So 25 is the same thing as 5 squared. 5 squared, 5 times 5 is 25. Then the powers will still remain there. 2n minus 3 equals to 5 raised to power 0. Now remember the law of indices that says that a raised to power x divided by a raised to power y is a raised to power x minus y. They have the same base. So if you look here, okay, let me quickly simplify this before I proceed with this law. Let's quickly simplify. Let's continue with this and I'll come back to this law again. So we have 5n plus 3. I want to quickly use this law here. Ax y. Remember this is the same thing as what? Ax y. Isn't it? You multiply the power. So that's what we are going to do for this. I will multiply the powers. So 5 divided by 5. So 2 times 2n will give me 2. It will give me 4n. I mean, to give me 4n. 4n. To give 4n minus 2 times 3, 6. 4n minus 6. So we have equals to 5 raised to power 0. 5 raised to power 0. So we are done with this law. Alright. So now I can now use this law. I will see that they have the same basis. This the same base 5 5. So I can obey this law. It's just their powers that are different. The power here, the power of x here is this, y here is this. So for this side, for this left hand side, I'll pick one of the 5, which is the base. Then I will subtract, because this is division, I'll subtract the powers. So that's n plus 3. This division will be minus in the power, minus. The power here is 4n, you put it in bracket, 4n minus 6. Put the second power in bracket, and it's equal to 5 raised to the power 0. Now take note, the bases are equal, because it's in this equation now. Whenever you have equal bases, they cancel out. So you would have noticed that I have been saying this since morning, equating the base. Equating the base. So equating the base means 5 will cancel 5 here. So you'll be left with n plus 3 minus 4n minus 6 equals to 0, because these are the powers. It's only the powers that will be left. Now let's open the bracket down here. N plus 3 minus times 4n will give you minus 4n. Because minus times plus is invisible plus here. Minus times plus will give you minus. So minus 4n. Minus times minus will give you a positive answer. So then 1 times 6 is 6 equals to 0. So now you can collect like terms. Collect like terms. So because of collecting like terms, you will have the following. You have this. When you collect like terms, you have n minus 3n. Sorry, n minus 4n. N minus 4n. That will be equal to all the numbers, all the ordinary numbers without n will come to the right hand side. So we have 0 here before. So 0, if 3 comes, it will become minus 3. If 6 comes, it becomes minus 6 also. So n minus 4n is minus 3n. And 0 minus 3 is minus 3. Minus 3 minus 6 is minus 9. Now, we are looking for the value of n. We divide both sides by the coefficient of n. What's disturbing n here? Minus 3. So we divide both sides. We divide both sides by minus 3. So that is minus 3n equals to minus 9 over minus 3 over minus 3. This will cancel this. You'll be left with n here. Minus divided by minus will cancel out. 9 divided by 3 is 3. So the value of n is 3. The value of n is 3. So you can test that in the equation. You realize that it is exactly the same thing. So the answer to this particular question is 3. So that will take us to the second example. I really hope you understand, and if you don't, you can ask question in the comment section. The next question says we should solve 2 raised to power 2x plus 1 equals to 32. Yeah, so this is also similar, just that we have something quite straight, probably the square root, and it is not part of the content of the topic at all, but it's something we should be familiar with. So let's see how to go about this. But the fact remains that the base is 2, and this one is 32. Is there a way we can express 32 as 2? Yes, I've explained it. I've explained how to go about this. Since this is 2 raised to power root of 2x, 2 raised to power root of 2x plus 1 equals to 32 is the same thing as 2 times 2 in 5 places. 2 times 2 times 2 times 2 in 5 places. So this 2 raised to power 5 is the same thing as 32. So this is just the same as this. Now that the bases are equal, equating the base means these 2 cancels these 2. So you'll be left with just the power. So the power 2x plus 1 equals to 5. 2x plus 1 equals to 5. Now, we are looking for the value of x. But there are a lot of things, there are a lot of factors around x. We have 2, we have the sum of 1, we have the root, the entire root of the whole thing. Alright, so what we take first is we try to find a way to take away the square root around it. So when you want to take square root away, you eliminate square roots by squaring both sides. Square roots, when you have something like x is equal to 4, the root of x is equal to 4, you will remove the square root. You eliminate it by squaring both sides. Squaring both sides means putting 2 as their powers, as the power for the two sides. So that this 2 will cancel this root. So you will see that x will gain freedom. And when x gains freedom, this 4 raised to 2 will mean 4 times 4. So whatever the answer is 16. 4 is 16. So that means the value of x is 16. And in the real sense, the square root of 16 is 4 in the initial question. Alright, so that's what you do whenever you want to eliminate, you want to eradicate square roots in mathematics. So we square both sides. Square both sides. So in order to eliminate square root, you square both sides in the equation. So squaring both sides, you have the whole expression squared and 5 also squared. Square the 5. So square, we cancel the square root here. You will be left with 2x plus 1 here. Then 5 square means 5 times 5, which is 25. That's 2x plus 1 equals to 25. Now the next thing is to collect like terms. When you collect like terms, you have 2x equal to 25 minus 1. 25 minus 1, that's 2x. Please manage the board. 2x, manage the board with me. So 2x, that's 25 minus 1 is 24. Now you divide both sides by 2. When you divide both sides by 2, you have 2x over 2 equals to 24 over 2. So that 2 cancels 2, and x is 24 divided by 2 is 12. So the value of x in this question, x is 12. In the question, x is 12. So that's that. Alright, so x is 12 in that question. We can move to the next one. The next question says that next question says we should solve for k in this equation. 1 over 8, then we have k plus 2. 1 over 8 raised to power k plus 2 is equal to 1. Alright, so this 1 over 8, from law of indices, 1 over a means a raised to power minus 1. I hope you remember that. So that means this is written as 8 raised to power minus 1. The whole of everything in the bracket means 8 raised to power minus 1. Then you have k plus 2, the power equals to 1 also. So let's see. 8, this is looking like this law, a to the power of x and y. That's a x y. You multiply the powers. So we use that law here. We apply the law here. A to be minus 1 times k will give you minus k. Minus 1 times plus 2 will give you minus 2 also. So that's that. Then you still have your 1 here. Now we have 8. 8 is the base here, and this is 1 here. How can we represent 1 as the power of 8? As something else, as a number that will be in the form of powers of 8. So the only way this can be 8 raised to power something, just like I said earlier, because this is 8 raised to power minus k minus 2. Minus k minus 2. Remember that I told you that a raised to power 0 is 1, as long as a is not 0. A raised to power 0 is 1, as long as a is not 0. So now this 1 here can be represented as 8 raised to power 0. This 1 here can be represented as 8 raised to power 0. 8 raised to power 0 is something as 1. So this is just exactly as the same as this. So now the bases are equal. So we equating the base. 8 we cancel it. That's what it implies. So minus k minus 2 equals to 0. Minus k minus 2 equals to 0. So for minus k minus 2 to be equal to 0, it means that minus k, we collect like terms, minus k equals to 0 plus 2. That's k equals to 2, minus k equals to 2. Divide both sides by minus 1. Minus 1 is the coefficient of k here. So when you divide both sides by minus 1, you have minus k over minus 1 equals to 2 over minus 1. So minus 1 cancels k, cancel minus rather. So k answer will be 2 divided by minus 1. The answer will be minus 2. Because plus divided by minus is minus. Then 2 divided by 1 is 2. So that's for now. Alright. Alright, so back to the recent. Okay, we are done with this question, so we can go to the next question. The next question says that 4 raised to power 3x equals to 16x plus 1. And we have to find the value of x now. To get the value of x, so we think just like what I said, you'll see there's a way you can express 16 as power of 4. So 4 raised to power 3x. 16 is the same thing as 4 raised to power 2. 4 times 4 can give you 16. So that will be there, x plus 1 now. So this 4 raised to power 2 is just the same as 16. So you still have the power as power. Now, remember the law I gave earlier also. Axy is axy. That's multiply the powers. That's how you got this. So now, 4 raised to power 3x equals to 4. We multiply the powers. 2 times x, 2x. 2 times 1, 2. So that now that the bases are equal, we can equate them. So on equating the base again, we have the 4 cancels 4 by this instruction. So we have 3x equals to 2x plus 2. So you collect like terms now. Collect like terms. So when you collect like terms, the x will come together. You have 3x, 2x will come here. It becomes minus 2x equals to, you have 2 left, 2. So 3x minus 2x will be just x. X will be 2. X is 2. So x is 2 here. So that's the value. The answer is 2. X is 2 for that question. Alright. So that will take me to the next number. So the next number says that 16 times 2x plus 1 is equal to 4x times 8, 1 minus x. And we are looking for the value of x in this question. For this question, we need to be very, very attentive. There's a word like very, very, if it is not a tautology. So we need to be very attentive in order to understand this particular question. It's not so hard. It's just what we've learned that we are going to apply. So we have 16 here. We have 2. We have 4. We have 8. They are all different bases. But you see, all these bases can be represented as power of 2. The least base here, the smallest base is 2 here. So let's see if you can express every other base as 2 also. So 16 will turn 2 raised to power 4 times 2 raised to power x plus 1 is equal to 4 will turn 2 raised to power 2. Remember the power x times 8 will turn 2 raised to power 3. Remember the power 1 minus x. Do you understand the concept? I hope you understand. So 2 raised to power 4 is 16. This is just still this. As well as this 2 raised to power 2 is 4. X is still x. 2 raised to power 3 is 8. And the power is still the power here. Alright, so now from the law of what's it called now? Indices. You see that these two have the same base. So we can pick one of the two so that we add the powers. So 4 plus x plus 1. You can put it in brackets. The second power in bracket. Second power, that's x plus 1 in bracket. Equals to 2. From that law I gave the other time that a is power x, the power of y is a x y. That's multiplying the powers. So we multiply these two powers also. 2 times x here will give us 2x. Is it clear? So times, we have 2, we multiply the powers here. So 3 times 1, 3. 3 times minus x minus 3x. So we have 2 raised to power 4 plus x plus 1. When you add all this, 4 plus x plus 1, you open the bracket, is still x plus 1. Since it is positive, the positive will just be exactly the same thing, positive 1. So 2 the powers, the bases are the same, so you bring one of the base and add the powers. 2x plus 3 minus 3x. Alright, so here we can equate the base. Equating the base, 2 we cancel 2, so we are left with 4 plus x plus 1 equals to 2x plus 3 minus 3x. When you see this plus 1 times anything is just that thing, so that's why this is just this. Now 4 and 1 are like terms. 4 plus 1 plus x. 2x and minus 3x are like terms. 2x minus 3x then plus 3. So this is 5 plus x. 2x minus 3x is minus 1x plus 3. So you collect like terms. Collect like terms. When you collect like terms, I'm leaving x, 5 will leave here, I'm leaving x, but 5 will leave this side. So it's only x that will be left here. Then this minus x is coming to this side, it will become x plus x. Now, when I've taken this minus x out, I'll be left with plus 3 here. Now, this 5 I said is coming to this side. So it was plus 5 before, it will become minus 5. So this is x plus x is 2x. 3 minus 5 is minus 2. 3 minus 5 is minus 2. So when you divide both sides by the coefficient of x, divide both sides by the coefficient of x. The coefficient of x is 2. So when you divide both sides by 2, you have 2x over 2 equals to minus 2 over 2. So x will be minus divided by plus is minus. 2 divided by 2 is 1. So the value of x here is 1 in this question. X in this question is 1. X in this question is 1. Alright, so I will take the next example, and immediately after the next example, I'll take this. I'll take this. I'm going to attempt this one. I'll take this. I'll leave this for you to attempt. Then I'll take this. And that will be the last question for this class. So let's see. The next question says that 16x equals to 0.25. Yeah. Alright, so this is this one. So we are looking for the value of x here. Alright, so 16 raised to power x, let it be there. Now what does this mean? I want you to understand this concept. If you have something like 0.062, for example, what you ask yourself is, what is the place value? You ask yourself, what's the place value of this last number? Now look at the place value of decimal number system is different from the place value of whole numbers. In decimal number system, let's say for instance you have 24.1570. This is the unit in decimal system. This is the tens, hundreds, thousands, tens of thousands, like that. Now, but immediately after decimal point, you have tens. This is a tenth. This means this tenth means divided by 10. This is hundreds. This hundreds means divided by 100. This is thousands. This thousands means divided by 1,000. This is tens of thousands. Tens of thousands. This means divided by 10,000. Do you understand? So you need to learn the place value of decimal numbers in order to know how to work with it. Now, how do I express this thing? This is a fraction actually. This is a decimal fraction. So you can express it in a proper fraction form. Now this is it. What's the place value of this last number? According to what I explained now, I said immediately after decimal point is a tenth. After the tenth, the next one is hundredth. Hundredth. So after hundredth, the last one here in this place is thousands. So the place value of this one is thousands. So you bear that in mind. So since you realize that it is thousands, just put thousands means divided by 1,000, like I said, 1,000. So over 1,000. Now you look at the number. Immediately after this is 0, this is 0. Once you see a number that is not 0, start from the beginning here. This is 0, this is 0. Immediately you see a number that is not 0, that's the first significant figure. From that first significant figure, write every other number downward. So because this is just 62 now, I'm going to write 62. Is it clear? So I'll just write Let's take another instance. If you have something like 0.0021, 0021. The place value of this last number is the first thing you get. This tens of thousands. Tens of thousands means over 10,000. Over 10,000. Now, you now go back to see the number. Where is the significant figure? The first significant figure is 2. You write 2 and every other number that follows it. So 2 and 1 are the numbers. So you write 21 over 1,000. That's what this number means. This number means 21 over 10,000. So if you have something like 0.4, 0.4, okay, let's say 0.42. The place value of the last number here is what you ask yourself. And the place value here is hundreds, which means over 100. Hundreds means over 100. Now, where's the first significant figure? 4. 4 and what? After 4, what are the other numbers? 2 is the only number, 42. So this means 42 over 100. So that's how to approach this kind of decimal fraction. And then express them in proper fraction form. Alright, so let's see. Let's apply that to this example now. So you can try it before, you can pause the video and try it and then play to see whether you are right or not. Alright, so for this one, the place value of the last number here is 5. The place value of the last number here is 5. And, the last number here is 5. The place value is 10th, 100. The place value of that last number is 100. That means we will have over 100. Now, the significant figure, immediately after decimal point, we have 2. So 2 is first significant figure. And what are the other numbers? 5. It's just 2 and 5. So it means 25 over 100. That's what this means. Alright, so now 16 raised to the power x equals to 25 over 100. This is not the lowest form. There's a number that can divide the two of them. 5 can divide this. If you use 5, you will have 5 back. If you use 5 to divide 25, you have 5. Use 5 here, you have 20. 5 can still divide the two of them. So 5 in 5 is 1. And 5 in 20 is 4. So in a nutshell, 25 over 100 is just the same thing as 1 over 4. If you divide 25 by 25, you get 1. Divide 100 by 25, you get 4. So this is it. Now, in law of indices, remember, 1 over a is the same thing as a raised to the power minus 1. So 1 over 4 means 4 raised to the power minus 1. From this law, if 1 over a is a raised to the power minus 1, that means 1 over 4 is 4 raised to the power minus 1. So now we have 4 raised to the power minus 1. Is there a way we can express 16 as 4 raised to the power something also? Yes. 16 is the same thing as 4 raised to the power 2. Then you have the x. So now, from here, we have 4. Remember this law also, ax again, and y is axy. So we are going to multiply the powers. That will be 4 raised to the power 2x. Because of multiplying, then you have 4 raised to the power minus 1. The bases are equal, so equating the base, you have these 4's cancel each other. 2x equals to minus 1. And then now you need to divide both sides by the coefficient of x. So dividing both sides by the coefficient of x, which is 2, you have 2x over 2 minus 1 over 2. 2 will cancel 2. So that x will be a negative half. So this will be the value of this answer. This will be the value of this answer. So you can pause the video and make attempts of answering this question I said you should try. Then I'll come back to this in a few minutes time. Back to the very last question. This question, we have two different equations with two variables, which indicates that we are going to approach simultaneous equation on the course of working on the exponential equation. So let's have it. 5. It said if 5 raised to the power x plus 2y is equal to 5, and 4 raised to the power x plus 3y equals to 16, that we should find the value of this 3 raised to the power x plus y. Alright, so I think this is fine. Let me just write it. 5x plus 2y. 5. This 5 is the same thing as 5 to the power 1. 5 is just the same thing as 5 to the power 1. So we can equate to this 5 cancel 5. So that you have x plus 2y equals to 1. This will be equation 1. Now for the second one, this was the first one. For the second one now, 4x plus 3y equals to 16. 4x plus 3y, we can express 16 as 4 raised to the power of 2. I've explained all this stuff, so I believe you understand now. We are equating the base. 4 cancels 4. You have x plus 3y, the powers equals to 2. So this is equation 2. So let me bring back equation 1. The equation 1 is this expression. X plus 2y equals to 1. This is equation 1. Equation 1, equation 2. So we are going to solve this simultaneously. To solve this simultaneously, we can solve using elimination method. So using elimination method, I know some of us will be expecting me to say multiply this by this, multiply this by this. But for this particular question, there is no need for that because the coefficients, the leading coefficients are already equal. The coefficient of x here is 1, the coefficient of x here is 1. So there isn't need for me to say multiply the equation 1 by this, equation 2 by this, because they have the same value of leading coefficient, just 1, 1. And even there is 2 here and there is 1 here now, I would have multiplied this with 2 and this with 1. So since they have the same 1, 1 as coefficients, as their leading coefficients, there is no need for me to multiply anything by anything. So I can just subtract one equation from the other. So let's say I am subtracting equation 2 from 1. Subtracting equation 2 from 1. Alright, so we want to subtract equation 2 from 1. We'll just be like our like those primary school mathematics now. Okay, so x, this is equation 2. We are subtracting 2 from 1 means you are assuming that 1 is greater than 2. So we'll be removing 1, then you'll be removing 2 from 1. So we'll have something like x minus x. 1x minus 1x. That's 0. So the x part is gone. This part is totally gone. Now we are left with this side. Now plus 2y. I'm going to write it out carefully. Plus 2y minus plus 3y. That's what you have on the left hand side. That's what you have left. Equals to 1 minus 2. So here you have plus 2y is same thing as 2y. Minus times plus is minus. Minus 3y. Minus times plus is minus. So this is minus 3y. 1 minus 2 is minus 1. 1 minus 2 is minus 1. So 2y minus 3y. That's minus 1y minus y. And then minus 1 here. So the coefficient of y here is minus 1. Divide both sides by minus 1. But in a nutshell, we know that when we divide both sides by minus 1, it will change the sign of the two sides. That's just the essence of dividing both sides by minus 1. Anytime you're dividing both sides by minus 1, it will change the sign of the two sides. The signs of the two sides. So this was positive, this was negative before. By the time I finish dividing, this will be y. When I divide this one by minus 1, by the time I finish dividing, it will turn to positive. It's negative, but it's on to 1. So y is 1. Now y is 1. We need to get the value of x. So we substitute the value of y into any equation. Let's use equation 1 because equation 1 is quite simple and softer. Into equation 1. So equation 1 is x plus 2y equals to 1. X plus 2y equals to 1. Now, we input the value of y. Y is 1. So x equals to, x plus 2. Then I replace y with 1 equals to 1. X plus 2 times 1 is 2 equals to 1. Then you collect like terms. When you collect like terms, x will be 1 minus 2. So plus 2 has turned to minus 2. So that will be x equals to minus 1. X is minus 1. Now the main question says we should find this. This is what the question says we should find. The question did not just say we should find y and x. The question says we should find 3 raised to power x plus y. So this is what we are finding. Now we just replace the x and y with what they are. So this will be 3. This will be equal to 3 raised to power x is minus 1 plus y is 1. So 3 raised to power 1 minus 1 plus 1 is 0. So what's 3 raised to power 0? Remember the law. A raised to power 0 is what? 1. So 3 raised to power 0 is 1. Since 3 is not 0, so 3 raised to power 0 is 1. So that's the answer for this question. Alright, so this is where we stop on indices and exponential equation. Thank you very much. If you have any question, you can drop it in the comment section.